Okay, so lesson 1.4, we're going to talk about rational numbers. So by the end of the lesson, you're going to be able to demonstrate how to convert between mixed numbers, improper fractions, and decimals. Okay, so rational numbers, what are they? Well, they're numbers that can be written in the form of A over B, so like in a fraction, where A and B are integers. Big pen on again. B cannot equal 0 because we can never have 0 as a denominator, otherwise we get an undefined number. We call A the numerator and B the denominator. Okay, so some examples of rational numbers: 2 over 3, 0.4, -5, -7 over 3, 0.3 repeating. That's what that little hat on it means, right? This is repeating. Or like 2 3/4. Anything that is a non-repeating or non-terminating, so like never-ending decimal, like pi or square root of 2, they can't be written as fractions. And if something can't be written as a fraction, then they would be an example of an irrational number, so not a rational number, and we wouldn't be talking about them. So we're going to take a look at some negative rational numbers. So we want to convert each of the rational numbers into decimals. So we're going to start off with one that we know, 3 over 4, and it's positive. So 3 over 4, you could use a calculator if you had to, but hopefully by now we all know that this is the same thing as 0.75. For part B, we have -3 over 4. So again, it's still 0.75, but now it's -0.75. So now that number, or the negative sign, being on the top of the fraction in B, or in C on the bottom of the fraction, isn't going to matter. Our answer is still -0.75. If we look at D and we have a negative on the top and the bottom of our fraction, two negatives, they cancel each other out, right? If we are to actually do -3 divided by -4, you're going to get a positive number, just like we talked about the other day with our integer rules. And then this last one, -3 over 4 with the negative being in the middle of the fraction. Again, it doesn't matter where that negative sign is. It's still going to give us -0.75 as our decimal number. So some conclusions that we can make about negative rational numbers is that they are the same as division of integers, right? If we have a negative divided by a negative, we get a positive. If we have a positive divided by a negative, we still get a negative, right? For example 2, we want to simplify the signs. So simplifying signs means, well, if we have -5 over -9, negative divided by a negative is a positive. So this is the same thing as just saying +5 over +9. If we have a negative on the top in part B and in the middle, it's the same idea as having two negatives, just like in example A. So this is the same thing as saying +8 over +15. In example C, we have two negatives inside the brackets, which give us a positive, but then this third negative on the outside of our brackets, that's going to stay, and we're going to end up with just a -2 over 5. Now, it doesn't matter where you put this negative. It can be in the middle, it can be on the bottom, or on the top. As long as there is one negative, your answer is correct. Okay. And then 1 over -6, most of the time in math, teachers do not like you to have the negative on the bottom or on the denominator. So I would suggest putting it on the top of your fraction or in the middle. So either of those would be acceptable answers. You generally don't want to have your negative with the denominator. Okay. So next we're going to cover converting between mixed numbers and improper fractions. So a number composed of a whole part and a fraction would be a mixed number. If we have four whole parts and 2/3 of another whole, then that mixed number would look like this. Okay, 4 is our whole number, and then 2/3 is our fraction, 2 being the numerator and 3 being the denominator. An improper fraction is a little bit different. So sometimes it's not helpful to have the two different parts, like the whole number and the fraction. Most of the time it's not. And it's better to just represent it as a single fraction. In these cases, the numerator is going to be larger than the denominator because it will have more than one whole part. So these are going to be called our improper fractions. Oops. Normally on a proper fraction, the numerator is smaller than the denominator. So if we wanted to convert a mixed number to an improper fraction, the easiest way to do it is to take your denominator, multiply it by your whole number. So in this case, we'd have 2 times 4, which is 8. And then we're going to take that number that we just got, so the 8, and we're going to add it to that numerator. So that would be 8 plus 1, and that gives us 9. And you just leave the denominator the same. So that would give us our 9/4 as our improper fraction. Okay, so then we're going to practice doing a couple of these, so writing them as improper fractions. So we have 4 and 2/3. So again, I would take the 3, multiply it by a 4, that's 12, add 2, and we get 14/3. Okay. In part B, we would take the 9, multiply it by 5. Again, it says -5, but you can ignore the negatives when you're doing this and just add them in at the end. So we know this is going to be a negative number. So take 9, multiply it by 5, that's 45, and then add 7 to that. So we're going to have 52. Yep. 9 times 5, 52/9. Right? Yes. So example 4, we want to write each as a mixed number. So how do we go backwards? So in this case, it helps if you know your times tables. So we have to think 8 can go into what? That's close to 45. So we know that 8 times 5 is 40. 8 times 6 is 48, so that's too big. So we want to go with the biggest whole number that's left. So 8 times 5 is 40, 5 becomes our whole number. And if 8 times 5 equals 40, we have 5 parts left over, so that is the part that's going to remain as a fraction. So the 5 leftover parts, and then 8 stays on the bottom. We can do this for part B with our negative number. Again, it's going to stay negative, so you can just leave the negative out in front and kind of ignore it. So in this one, we want to think of our 6 times tables. So we know 6 times 7 is 42. 6 times 8 is 48. So that's even closer. So 6 times 8 is 48. So that means we're going to have 8 wholes, and we're just 1 shy of 49, so we're going to be left with 1/6. Okay. All right, so we want to convert back and forth between mixed numbers and improper fractions. Sometimes it's going to be more appropriate to have a mixed number as an improper fraction or vice versa, so we should be able to go back and forth between the two forms pretty easily. I will say most of the time we will be using an improper fraction more than we would use a mixed fraction. So the other thing we're going to talk about is equivalent fractions. So for every fraction, there's an infinite number of equivalent fractions. You can just pick any number to multiply them by or divide by, and you'll get an equivalent fraction. So if we did something like a half, if we multiplied top and bottom by 2, we would get 2/4. Right? As long as you do the same thing to the top as you do to the bottom. We could carry on that pattern, and multiply this one by 2, and we'd get 4 over 8, which is still equivalent to a half. We could have taken the top and the bottom and multiplied them both by 3, and we would get 3 over 6. Uh-oh. What happened to my pen? Oh no, my pen stopped working. Hopefully I can get it. Oh, there it goes. So we'd get 3 over 6. We could have something like 16 over 32, right? If we were to multiply the top and the bottom by, from a half by 16, right? We can keep going on and on forever. The idea is that they are proportional. What we do to the top, we do to the bottom. So we can figure out missing numbers if we think of equivalent fractions. So in the second example here, we want to figure out a missing numerator. We know 5 is the denominator and 20, and we know that 5 times 4 is 20. So that means whatever we did to the bottom, we want to also do to the top. So we want to do 2 times 4, that gives us 8. And then we can carry on the pattern here. So here we have 8 and we're going to 24. Well, 8 times 3 is 24, so we want to do the same thing to the bottom. 20 times 3 is 60. And then if we want to do this last one, we got 60 and we're going to 10. Well, in this case, it was divided by 6. So we want to do the same thing to the top, divide by 6, and we end up with 4. Okay. And then example number 5, we want to just determine an equivalent fraction. We're going to use the same rule, so whatever we did to the bottom, in this case multiplied by 2, we want to do to the top, so that'll give us 4. On this one, we multiplied the top by 5, so multiply the bottom by 5, and we get 35. On this one, we multiplied the top by negative 11 because it went from a negative to a positive, and then we want to multiply the bottom by negative 11, and negative 17 times negative 11 is 187. Okay, so make sure that you are also watching out for signs. So another thing when we talk about fraction is reducing them. So you probably were told in elementary school a lot about reducing fractions, hopefully. So now that we know how to write our equivalent fractions, but most of the time we don't want to leave them as these big numbers. We want to write the fraction in lowest terms because it's easier to work with small numbers. So to reduce a fraction to lowest terms, we're going to keep dividing the numerator and the denominator by the, this should say same number that goes into both of them. So we're going to try a couple examples here. So we're going to reduce each fraction to lowest terms. Okay, so we've got 18 and 81 here. Well, if you think of your times tables and like factors of the same number, we know that 18 can be divided by 9 and so can 81. So we want to divide top and bottom by 9, which would give us 2 over 9. And there's no way to reduce that any farther. We have an even and an odd number, so it's not going to work. In the second example, 24 and 60, well, we know our answer is going to be negative because we shouldn't be changing that. Both of them can be divided by 12. So if we divide top and bottom by 12, we get 2 over 5. And again, smallest number that we can possibly get. If we have a mixed number, you don't have to change it to an improper fraction. You can just leave the whole number out in front, and then it's actually the fraction part that we want to reduce. So this one, you might not think of it right away. Both of them can be divided by 18, but a lot of people wouldn't necessarily think of that. They might have thought of 9. So if you did 9, that's okay. So 36 divided by 9 is 4, and 90 divided by 9 is 10. But you have to stop and take a look and think, can I reduce further? Well, you can here, because you have 4 and 10, and we know both of those could be divided by 2. So make sure you get to this absolute smallest number that you can. Oops. Wow. Scroll fail. Okay, so make sure every time you have a question in math, you must answer with fractions in the lowest terms. So it's really good to practice these. We're going to practice a couple more of them and take care of signs as well in these ones. So we have 4 over 18. Both of these we can divide by 2. We get 2/9. 72 and 81, both of them can be divided by 9. 9 times 8 is 72, and 9 times 9 is 81. Now here we have this negative on the bottom. I would move it to the middle or to the top to make your math teacher happy. Because, like I told you before, math teachers aren't a big fan of those negatives on the bottom of a fraction. We have 55 and 121. Hopefully that makes you think of 11. So in this case, we would divide both by 11, so we have 5 over 11. And because we had 2 negatives, that gives us a positive. And then number 4 here, 52 and 62. Well, the only thing that we can do is really divide these by 2. They're both even numbers, so that should work. So 52 divided by 2 is 26. 62 divided by 2 is 31. We have 2 negatives, which give us a positive answer. Okay. So a couple more here. We want to convert decimal to a fraction. So if we want to convert to a fraction, the easiest way to do it is to follow these 3 steps. So step 1, we want to determine the place value of the last number of the decimal, and that becomes the denominator. So I'm going to get rid of this 0 point, and I'm just going to put 625. That's going to become my numerator. And because this is the tenths, hundredths, thousandths, I'm going to put 1,000 on the bottom. So that's step 1. And then again, so I said step 2 was make the decimal my numerator, which I already did. And step 3, we want to reduce our answer to lowest terms. So in this one, I'm not exactly sure what the number would be, but I'm going to try 25 because that will definitely work for both of these. That's going to get me 25 over 40, but I could definitely divide both of these by 5 still. So I'm going to get 5 over 8. Okay. So a little hint here, okay, your denominator is going to have the same number of zeros as there are decimal digits in your decimal number. So in this case, we started with 0.625, so it has 3 decimal digits, so the denominator should have 3 zeros. So that's why we had 1,000, right, with 3 zeros. Okay, and then we're just going to try a couple more examples to convert here, and then that's it. So we're going to take the 0.45, make 45 our numerator, and then our denominator is going to be a 1 with 2 zeros. Okay. Both of these could definitely be divided by 5 to reduce, and we're going to get 9 over 20. In part B, right, we know it should stay a negative, and then 8163 as the numerator. Our denominator should have a 1 with 1, 2, 3, 4 zeros. Okay? And as far as I'm aware, this one does not reduce. You can try, but I cannot find a number that goes into both of these, so then that would be your final answer. And then this last one, 12.12. Well, what happens if we have an actual number other than 0 before the decimal? Well, that becomes a whole number, right? It's a mixed fraction. And then we're going to put what's after the decimal as our numerator, and then our denominator, again, a 1 with 2 zeros because of these 2 numbers. And then we want to reduce this. These both divide by, not 2, I could do 4. 4. And we'd get 3 over 25. So that's our quick lesson on rational numbers.